Determine all solutions for the following equation over the specified domain. So our equation is 3 tan of x is equal to root 3, and we're wanting to solve this over x as an element of negative 2 pi to 2 pi. So this domain, negative 2 pi to 2 pi, contains 4 periods worth of the tan graph. And that's because the period of the tan graph is equal to pi divided by n, where n is the value that is multiplied by x, so in this case n is equal to 1, which means the period is just equal to pi, and pi fits into the domain 4 times. So to solve this equation we want to get tan x by itself, so we're going to divide both sides of the equation by 3, so we are in fact solving tan of x is equal to root 3 over 3. And now root 3 over 3 is an exact value that you should know for tan, and the reference angle is theta is equal to pi on 6. And that's because if we have pi on 6 as our angle, that gives a y value of root 3 over 3. So this angle here is pi on 6. And now the other quadrant where tan is positive, because we have a positive value that we're trying to get tan to equal, is in the third quadrant, so down here. And this is going to be pi plus pi on 6. So the symmetries of the unit circle, this first quadrant is just theta, and this is pi plus theta. So we want x to equal theta and pi plus theta. Therefore, x is equal to pi on 6, our reference angle, or pi plus pi on 6. So therefore, our values of x are going to be pi on 6 and 7 pi on 6. And you may be wondering why I've left all this space before it, and that's because there's a few more solutions that we need to find which occur in the negative 2 pi to 0 part of this domain. So the first two solutions that we found were in one cycle of the unit circle, going from 0 to 2 pi. And now if we go from 0 and backwards to negative 2 pi, we're going to get two more solutions. So the solution down here would be negative pi plus pi on 6. So we have another solution at negative pi plus pi on 6. And the other solution that appears, which is here, is going to be the same as going negative 2 pi plus pi on 6. So we're going to have negative 2 pi plus pi on 6. So these are 4 solutions that sit within the domain of this question. Another way to think about that is we can take one specific solution and we can subtract the period from it, which is pi, and then we can take that solution and subtract a period until we go outside the domain of our question. So simplifying down what we've found, our values for x, which are a solution to this equation, are going to be negative 11 pi on 6, negative 5 pi on 6, pi on 6, and 7 pi on 6. So they are the 4 solutions to this problem. Over on this slide, we've got a computer to graph y equals tan of x in blue and y equals root 3 on 3 in red. And that's because the equation that we were trying to solve became tan of x, which is the blue, is equal to root 3 on 3, which is the straight line in red. And the 4 solutions, negative 11 pi on 6, negative 5 pi on 6, pi on 6 and 7 pi on 6 are all the same as the ones we found by hand on the previous slide. We can also see that each of these 4 solutions lie one period away, which is pi for this question. So if we take 7 pi on 6 and subtract pi, we get to pi on 6, subtract pi again, and we get to negative 5 pi on 6, and finally if we subtract pi, we find the last solution inside this domain, which is 11 pi on 6.